test. Until now we were discussing about the random number generation by using various methods. The first one is by using the LCM method, the linear congruential method, and second one was the combined linear congruential method, and last one is by using the random streams. So here the random numbers which we have generated, we need to test these random numbers. What are the things we are going to test for this? As I said you, the random number, it should have a property of independence and uniformity. So here the two tests we are going to conduct to test for uniformity and independence. So let us consider that right now let us test for the random numbers. There are two categories. As I said you, the very first test is for testing for uniformity. So here when you are testing for the uniformity, the hypothesis, here we do consider the hypothesis H naught. The hypothesis H naught, it states that if the random number Ri, when we take it the Ri, which if it is uniform within the range, we can say that the Ri is a uniform within the range, that is 0 to 1, that is given as u of 0, 1. What it is written here, it means that it is lying within 0 to 1, which is completely uniform. Now the hypothesis 1, it states that if R1, here if it is H naught is going to fail, we can say that here it's going to reject this first hypothesis H naught. We do call it as a null hypothesis. The null hypothesis. Here the H1, that is the random number, if it is not lying between 0 and 1, it is not uniform between the 0 and 1, is there the H1, the hypothesis. So the very first thing is that H naught, if there is a failure to reject this null hypothesis H naught, it means that the evidence of non-uniformity has not been detected. It doesn't mean that the very first thing, the null hypothesis here, if it is rejecting, it is not able to reject, or if it is not true, it doesn't mean that completely this is a false one. So here we do say that it has a non-uniformity, but still it has not been detected. So this is how we are going to test that the null hypothesis. If it is a failure to reject this null hypothesis H naught, it means that the evidence of the non-uniformity has not been detected. That's what we do say that. Testing for independence. The testing for independence, again as I said you, the hypothesis testing, the null hypothesis states that the random number, it is completely independent of the previous numbers or the next numbers what we do take it. So the null hypothesis H naught says the random, it is completely independent. The H1 states that it is not independent. Ri, it's been given as it is not independent. So here also I do state that if at all if there is a failure to reject this null hypothesis H naught, it means that the evidence of dependency has not been detected. Okay, if it's rejected, the failure, that is the failure of rejecting this null hypothesis means the evidence of proving this dependence has not been detected. So the next comes is the level of significance given as a alpha. So here the level of significance, and what is the probability of rejecting this H naught when it is not true or when it is true. So here when we take it, the level of significance alpha, that is given, that is alpha, the probability of H naught, or we can say that the probability of rejecting the H naught when it is true. So this is given as alpha, the is P of, that is rejecting, we can say probability of rejecting the hypothesis H naught when H naught is true. So here this gives you the level of significance to find this. Okay.